So starting with the pop quiz 12 discussion, which was related to space and atomic physics. In the first question, only one isotope of the gold occurred naturally. So if we have only one isotope occur naturally, said what does indicate about the nuclear structure of all naturally occurring gold atoms? So what we can say about gold if we say that it has only one isotope? So we can say that they all have the same number of neutrons because if there are different isotopes, they have different number of neutrons. So if there is only one isotope naturally exists, then we say they all have same number of neutrons. The second part, there are several artificially produced isotopes of the gold are there. Gold 198, which is 79, and 198, which is an artificial isotope. It is used in medicine and scientific research, and it decay by emitting out beta to become a stable mercury. Determine the number of proton and neutron in the nucleus for isotope of mercury. So first thing, we have to write equation like what will happen. So we have first gold is there, which is 198 and 79. Because it is emitting out beta, whenever there's a beta particle emission is there, the nucleon number does not change as the neutron converted into proton. So one neutron decrease, one proton increase, but the nucleon number does not change. So it will be 198. But the proton number increases by 1 in a beta decay, negative beta decay increases by 1, and this is for beta. Now the question is, we need, for this mercury, we need how many protons are there and how many neutrons are there. So to get the number of the protons, the proton number is already there, like this is a proton number, so that is equals to 80. But to get the number of neutron, we subtract 198 minus 80, which is equals to 180. So 180 neutrons are there, and there are 80 protons. Is it clear, this one? The next question is related to space physics. Light from glowing hydrogen in a distant galaxy is a redshift. What is meant by the light, by a redshift of a light? What is the meaning of a redshift? Basically, what happened? The wavelength which we observe, wavelength which is emitted out, and the wavelength which we observe, it appear to be longer. So how we define a redshift will mention the wavelength which we observe appear to be longer than the wavelength which is emitted out. Maybe the star or the galaxy might emit out a wavelength of say 700 nanometer or 650 nanometer or 670 nanometer. That is a wavelength which is emitted out from the star. But when we observe this wavelength, what we receive a longer wavelength. We don't receive 670. As this star or a galaxy is moving away from us, so we observe a bit longer wavelength, and that is called a redshift. It's not like longer wavelength is emitted out from the star, but when we receive that wavelength, it appeared to be longer than what was actually emitted out from the star. So what is meant by the redshift, the definition of a redshift? So how we define, we'll mention the wavelength which we observe appear to be longer as compared to a wavelength emitted out from the star. You don't have to memorize the color. You don't have to memorize the wavelengths as well. You don't have to. So the wavelength observed appear to be longer than wavelength emitted out from distant galaxy. So they are emitting out certain wavelength, but when we receive that, it appears that it is a longer wavelength. State what can be deduced from a redshift of a light glowing hydrogen. And so if it's a redshift, if the question is define the term wavelength, then this is enough for definition. Like 1 mark you will score when you mention the wavelength which wavelength appear to be longer, and 1 mark compared to the wavelength emitted out. That's it. That's enough for redshift. You don't have to write like it appears that it is moving up. The second part, what can be deduced from a redshift of a light glowing hydrogen in a distant galaxy? Now, if a light is redshift, like what we can deduce from this, we can say that the star or the galaxies are moving away because of redshift. And what else we can do? We can also calculate, like this is 1 mark when you mention using a redshift, we can say they are moving away from us. And the second thing, we can also calculate the speed at which they are moving. Like this is 1 mark, redshift show they are moving away. The second thing, like what can be deduced from a redshift of the light? So we can find the speed of the galaxy by comparing the wavelengths. So how much the wavelength change, that can be used to work out the speed at which these galaxies are moving. So using a redshift, first thing, redshift shows that this galaxy or a star is moving away from us. And using that redshift, the change in the wavelength, we can work out the speed at which this star or a galaxy is moving away from us. In part B1, state one method of estimating the distance of a galaxy from the Earth. So how we can work out the distance of a galaxy from us? The simple thing, what we use normally, we use the brightness, like the brightness of a supernova in the distant galaxy can be used to work out its distance from us. Like what actually happened because of a supernova, enormous amount of a light emitted out from that galaxy. And from that light, we can find like how far this galaxy is from us. So one method of estimating a distance, one method is like if you want to estimate, that is the Hubble's law. If you remember, V is equals to H naught D. This is one method. What is another method? We can use by using a brightness of a supernova. Because different galaxies, they have like supernova happen any part of the galaxy, and that is the main pinpoint. Like using a supernova, we can identify like how far this galaxy is from us. Then how, according to a Big Bang theory, 1 over H naught represent the age of the universe. Like this is sometimes they ask this derivation, sometimes they ask in explanation. So this question is an explanation, but sometimes the same question is show that 1 over H naught is equals to age of the universe. They can ask in that way as well. So what are the points you will mention? Like how 1 over H naught is equals to the age of the universe. So idea is that according to Big Bang theory, everything was like 1 point in space. And then what happened that when everything exploded, the distance of a galaxy traveled, how far it traveled, that is d, and the speed at which it is moving is v. So using that, we can work out the time. Like the idea is that everything was 1 point. Say this was a point, the start of the universe. Then when it exploded, and the temperature also changed for the universe and the formation of different structures and system. But when it exploded, example, this galaxy A is move a distance d from here. So idea is that what actually we are doing, like Earth was also the part of this singularity different galaxies which we are observing now was also part of this. So what we are considering, we consider like when we are observing any galaxy or star, so that galaxy or the star was actually part of the Earth, or Earth was actually part of that galaxy. So how much distance traveled by this galaxy and the speed at which this galaxy is moving. So using the ratio between distance and speed, we can find the time, and that time is known as the age of the universe. Because like everything was one due to explosion, everything scattered, how much distance travel and what speed this object is moving. So using a distance over speed, we can find the time, and that time is a point where, like for example, when we calculate this example, we got the answer as 10 seconds. So what does it mean? It means before 10 seconds, this galaxy was part of Earth. Example, like we are getting a age of a universe about 1.4 billion, so 14 billion. So same idea is that when it explode and move away from the Earth, so the distance this galaxy is having and the speed at which this galaxy is moving. So we just take a reciprocal of a distance over speed. So we can find that the Earth was not center, but the idea is that Earth is not center of the galaxy, or we are not saying Earth was center. We are saying like these two things, the galaxy which we are observing was part of the Earth, or Earth was part of that galaxy which we are observing. So how far this galaxy move away from us, it means, because it's like everything was one point and then it explode and then everything tend to move away from each other. And it's not like we just calculate this time for one galaxy when we collect a different set of result. So there is a lot of uncertainty in that the age of the universe, but still we are getting a range of answer which are closer to each other. So when we observe another galaxy and the distance is there, maybe the distance is shorter, but the speed at which it is moving is also smaller. So when we calculate the distance divided by speed, we get the time, and that time is known as the age of the universe. And the time taken by galaxy A is approximately same as the time taken by galaxy B, even though they are different distance from us. Because we know, according to Hubble's law, those galaxies or those stellar objects, distant galaxies, which are far from us are moving much faster as compared to the galaxies which are closer to us. So the one which is moving faster will cover greater distance as compared to the one which is closer to us. But when we calculate the time, we get the same time, and that shows the age of universe. So how you will write this answer, like whenever a question is there, how 1 over h naught represent the age of the universe. So one point, that according to Big Bang theory, all galaxies or matter originate from one point. So everything was like all together. So according to Big Bang, it all start from one point. That is one mark. What about the second mark? The second mark will mention like if a galaxy is traveled like how from when it was in contact with the Milky Way galaxy, say a distance is d and the speed is v. So the distance of a galaxy is d, and the speed at which the galaxy is moving is v. So when we take a ratio between d over v, that is equals to time, and that time is 1 over h naught. Like, because according to the Hubble's law, that speed at which the galaxies are moving, that's equals to Hubble's constant time t. So v over d is equals to h naught. If you take a reciprocal, it will be d over v is equals to h naught, 1 over h naught. If we take a reciprocal, and d over v is equals to time, so time is equals to 1 over h naught. So these are the 3 points. One mark mentioning that according to Big Bang, all start from one point, singularity. Then the distance of the galaxy is d and the speed at which these galaxies are moving is v. So if we take a ratio between d over v, we get the time, and that time is equals to reciprocal of the Hubble's constant, which is also known as age of the universe. Is it clear, this one? Part B2? Anyone having a doubt or a question in this?
Oh, sir.
Okay. So this was a pub quiz 12, which was related to space and atomic physics.